Impacts and collisions, 2014, question 5A. Two smooth spheres, A and B. A is mass 2m and speed u. And B is mass 7m and it's at rest. A is going to strike B, and B is then going to go and strike the wall. The coefficient of restitution is 1/2 for all collisions, but we're told in part 1, show they will not collide for a second time. So let's apply the principle of conservation of momentum to these two spheres. M1u1 plus M2u2 is equal to M1v1 plus M2v2. So I've got 2mu, this is speed is u, plus 7m by 0, so at rest, is equal to 2mv1 plus 7m v2. Knock out my m's, and I get 2u is equal to 2v1 plus 7v2. If we apply Newton's experimental law, v1 minus v2 is equal to, we can bring we know it's over u1 minus u2, so minus e times u1 minus u2. If you want to write it like that in the first step, you can. So v1 minus v2 is equal to minus 1/2 by u1 minus u2, which was u minus 0. So we get 2v1 minus 2v2 is equal to minus u. So I need to solve these two equations for v1 and v2. So you can see here I have a 2v1, so why don't I make that top line negative, or this line here negative. If I change, I'll change color. Minus plus plus, and then bring this line down. I'm going to get 2v1 plus 7v2 is equal to 2u. So I'm going to get 9v2 is equal to 3u, or v2 is equal to 3u over 9. 3u over 9, which is equal to u over 3. Let's have a look at getting v1. What could be the easiest equation to get v1? It's probably this one here, 2v1. We had minus 2v2 is equal to minus u. So if we put 2v2 in, we're going to get 2v1 minus 2u over 3 is equal to minus u. So we're going to get 2v1 is equal to minus u plus 2u over 3, or minus a full 1 plus 2/3, which is minus a third. 2v1 is equal to minus u over 3, and then to get v1 we're going to have to divide this by 2, which will give us minus u over 6. What does this mean has happened? It means v1, A has hit B. It's going in this direction with positive u, and now it's going in this direction at minus u over 6. I think we got minus u over 6. So let's get v. B will have to be greater than minus u over 6 to catch up with it. So let's have a look at the new velocity, v3. v3 is after B hits the wall. We need to apply the coefficient of restitution to its velocity. So u over 3 by minus e is equal to v3, and minus e was a half, set for all collisions, didn't it? So the half was for all collisions including the wall. That was the second collision they were telling us it was 4. So u over 3 by minus 1 over 2 is equal to minus u over 6. So we can see here that they're actually traveling at the same speed. So v3 would have to be greater than v1, but v3 is equal to v1, so no more collisions. Part 2 of this question, find the total loss of kinetic energy, 1/2 mv squared, due to the impacts. Okay, so what we have is we have A, was A and B, wasn't it A and B? We have A and B, so we have the kinetic energy this is at rest, so we're talking 0 for this one. So we have the kinetic energy of A before, and then we have the two kinetic energies afterwards, and both those speeds were u over 6, and the speed of A was u. So before is a half mv squared, and this is for A, so a half mu squared. So that's going to be, no, the m was 2m, wasn't it? 2m was 2m, so a half 2m to be squared is going to be 4 mu squared so just the u to be squared, so it's a half 2m by u squared, which is just mu squared. So that's before. After, my mass is 2m and 7m. The speeds are the same. So we have a half 2m by, what was the u over 6 up here? U over 6 to be squared. And we had a half of 7m, also u over 6 to be squared. So we have mu squared over 36, it looks like. And we have 3.5. So I'll just write it as 7m over 2 u squared over 36. So that's, they're both going to be over 72. So 2m u squared over 72 plus 7m u squared over 72. It's going to give me 9mu squared over 72, and 9 goes in, that's 1 over 8, so that's mu squared over 8. That's what's the kinetic energy afterwards. It started at mu squared, so the loss is mu squared minus mu squared over 8, which is going to be 7/8, 7mu squared over 8. That's the loss of kinetic energy.